All right, now let's work a problem with this. So rank the melting points for each of the following, one being the highest. So we need to identify what's going on here. We have several different compounds. We have an amine here. We know just from looking at those structures that this hydrogen is directly bonded to this nitrogen, and so there is going to be some hydrogen bonding. If we look at lithium chloride, this is ionic. This is not a molecule at all. It doesn't have intermolecular forces. It has that strong electrostatic attraction between the positive lithium ion and the negative chloride ion existing in that crystal lattice structure. So we have ionic going on here. The next one is going to end up being dipole-dipole. The compound would look like this if you were to draw it out. And so we have nitrogen bonded to carbons in three different directions here. So this is going to be a polar type molecule. There's an unshared pair on the molecule as well. So you are going to have a non-symmetrical molecule, which will result in a polar molecule, which will have dipole-dipole interactions with other molecules of the same type. This next one, we have another amine, and so we're going to have hydrogen bonding again. Now, we have this information. We can make our decisions on which one has the highest melting point. So ionic is much stronger than any intermolecular force, so it takes more energy to break those ions apart, so it is going to have the highest melting point. So we would put, that would be number 1. Then we have 2. Our next strongest is going to be hydrogen bonding. So we have 2 things here for hydrogen bonding, and we have to decide which one basically has stronger hydrogen bonding. And with this one, we're going to go with the larger molecule. Since there are more electrons, there's more polarizing, it's more polarizable, and so our hydrogen bonds would be stronger for that one. So that is number 2, and then our other amine, which has hydrogen bonding, would be number 3. Leaving the dipole-dipole interaction to have the lowest melting point at number 4. Okay, now we have some more practice. Take a moment and see if you can figure out, go ahead and pause the screencast to see if you can figure out the ranking for these boiling points. Okay. What we have here, we have an ester, so this is going to be polar. No hydrogens are directly attached to this, so dipole-dipole for this one. Again, we have dipole-dipole interactions because we don't have a hydrogen directly bonded to F over N. Here we have all C's and H's, so this is going to be non-polar. So we'd have London dispersion forces, and then we're going to have another amine, which we already determined in the last problem has hydrogen bonding. So we want them in terms of increased boiling point. So we want the one with our increasing boiling point. So we want the lowest boiling point first. That means the one with the weakest intermolecular forces. So our alkane, here, this would be butane, would be first. Then we have our 2 esters here, which both have dipole-dipole interactions. The dipole-dipole interactions will be weakest here because this is a smaller molecule, so it's less polarizable. And so that would have our next highest boiling point, followed by this one. It's larger, so it's going to have more our higher boiling point. It takes more energy to break those stronger forces of attraction. And then our last one would be hydrogen bonding. So the correct answer would be B right here. Okay, now take a minute and see what you can do with the second problem. All right. In this problem, they're asking you about the states of matter that each of these molecules would be in. Intermolecular forces are the reasons why gases are gases. They have weak intermolecular forces, so it takes less energy to break them. So the temperature, the heat in the room is enough to break those intermolecular forces. If we have stronger and stronger intermolecular forces, if it can break some of them, it's a liquid. If the heat in the room can't break any of the intermolecular forces, then it is a solid. So for this one, we have a nonpolar molecule. We have a nice polar molecule with hydrogen bonding. So this is an alcohol. And then we have an ionic compound. The ionic compound has stronger forces of attraction, so it is going to be our solid. The energy in the room would probably be enough to break some of the attractive forces, but maybe not all of them. So I would expect this to be our liquid. And F2, it's a small molecule. It only has limited dispersion forces, which aren't going to be very strong because this molecule is so small. So the temperature in the room or the heat in the room is enough to break those intermolecular forces. And we would expect this one to be our gas. So the correct answer for this one is A. The stronger the intermolecular forces between molecules, the lower the substance's vapor pressure. The intermolecular forces are what has to be broken in order for a substance to be able to evaporate. Volatile substances like fingernail polish remover or acetone evaporate very, very easily. So do you think they have strong intermolecular forces or low intermolecular forces? Well, the correct answer is low intermolecular forces. That way, the heat of the room is enough to break those intermolecular forces, and then you can smell acetone immediately because it is evaporating into the air. So if we're looking for something that has the highest vapor pressure, we're looking for something that has the lowest intermolecular forces because it's going to be giving off a lot of vapor. If we look at our compounds here, so again, we're looking for lowest intermolecular forces. I see we've got some hydrogen bonding down here on D and E. So we would immediately eliminate those because the others only have C's and H's, so they are nonpolar and would only have London dispersion forces. So now I have to make a decision between those and also the temperatures changing. Well, the difference between A, B, and then C is this molecule is slightly smaller, so it would have lower London dispersion forces if we were looking at them at the same temperature. It's also at a higher temperature than this larger molecule here. So I would say that the one most likely to evaporate more would be C, and it would have the highest vapor pressure because it would have the lowest intermolecular forces. Here's another practice type problem, and in this one, they're actually giving you a measurement of the polar nature of the bond. And it does have these units here with a capital D, and it's the dipole moment. So this molecule, which is going to be difluoroethane, has a dipole moment of this, and here's its boiling point. Another very similar, this is dichloroethane, has a smaller dipole moment. So the polar nature of the bonds is a bit less, but it has a much higher boiling point. And they're asking, why is that so? So read through the answer choices and see if you can come up with the correct answer. Okay. I would have to say that D is the correct answer for this problem. This is not going to be, this is more polar, but if they are more polar, they have stronger intermolecular forces. And if they have stronger intermolecular forces, they are going to have a higher boiling point. So this last part didn't match up with the answer. This is not ionic, so that eliminates B. They're both molecules. C does not have hydrogen bonding. Hydrogen is not directly bonded to F over N, so it cannot be C. CH2Cl2 is a much larger molecule than difluoroethane. And because of that, it has a larger molecule. It is going to be more polarizable, and as a molecule, you will have stronger intermolecular forces than in CHF2. The last thing I want to talk about is viscosity. Viscosity is the resistance